Hello again, everybody. So I decided to make an additional video just in case that goes over some of the Delta Math problems, but also some that are a little bit different than the Delta Math problems. But again, it's a if you can dodge a wrench, you can dodge a ball type thing. So let's talk about this first one. Let's remember our goal for equations. If we are solving an equation, that means, number one, we have to have an equation. If we just have an expression with no equal sign, then we're not solving anything. We would be simplifying or something like that. But in this case, we are solving for a specific variable, and this thing will tell us which variable we're solving for. When we only have one variable, we get a single solution that's usually a number. If we have more than one variable and we are solving for one of them, we're probably going to still be left off with variables. It doesn't matter. It's telling you the relationship between your input and your output, or your unknown quantities, things like that. It's just sometimes it's more convenient to solve specifically for a variable. So our goal here is, if our variable is x, our goal here is to have x equals some stuff, or some stuff equals x. So you'll notice that this thing is messing up on me. You'll notice x is by itself with a 1 coefficient, so it's invisible. A 1 power, a 1 denominator, a 1th root. It doesn't matter. It's basically just x, and there's nothing else that's interfering with. You could put adding 0 if you want. It doesn't matter. But we just write it as x. So that's our goal. I mean, we want to keep our goal in mind. So in this case right here, I have 17 plus 5x equals negative 23. So we have our goal. Our goal is to solve for x. So we need to come up with a plan. So I like to go in the opposite order of operations. So I like to fix my addition and subtraction first, because it's easier. You do not have to do that. So when I'm looking at this thing, I'm looking at 17 plus 5x equals negative 23. So I don't like this positive 17. That's a term all by itself. That is why I'm going to subtract that term. I don't want to accidentally confuse that with multiplying or dividing. It's just this term by itself. I don't want it on the left side. I want to get it over to the right side, because I want to have my x by itself. So on the left side, I want to ask myself this question. 17 plus negative 17, or 17 minus 17, is 0. So when I'm adding or subtracting a term of 0, it doesn't do anything, so I don't write it. So that's why cancellation happens when we're adding or subtracting. You might get annoyed with me saying that over and over again, but I just don't want you to cancel when you don't know why it's canceling. And then on the right, we have negative 23 minus 17 is negative 40. Very easy to make a tiny mistake here and do 23 minus 17 and ignore the negative. Make sure that you're aware, and that you're with it enough in that moment, that you're thinking about it enough that nothing gets lost. Okay, so that was my first step. This thing promises it's 2 steps. So I don't have any more addition or subtraction to take care of, so let's look at multiplication and division. I don't want this 5 here. To get rid of a 5 coefficient, I look at it and say, hey, what's that 5 doing to my x? Well, it's multiplying. So to undo that, I either need to divide both sides by 5, which will get me my answer of x equals negative 40 over 5 is negative 8. So if I do it like this, where I'm dividing, the 5's cancel, because they become 1 in that fraction. There's no addition or subtraction in the numerator or the denominator. There's no extra stuff. There's just, it's a factor that is in common in the top and the bottom, so they cancel. It's because 5 over 5 is 1, and multiplying by 1 doesn't do anything. Now, I want to point out, because I talk about it a lot, but I don't show it a lot. Dividing by 5 is the same thing as multiplying both sides by 1 over 5. You might wonder why I'm writing it like this, but a lot of students say, this thing's not a fraction, how do I multiply by a fraction? Well, you put it over 1 if it's not a fraction, and then you do top times top over bottom times bottom. That's pretty much it. That's all there is to it. It means the same thing. Do you need to do this every time? No, but using the reciprocal saves us effort and makes things easier later on. You'll get the same answer, 5 over 5. So if I were to rewrite it, I could write it as 5 over 5 times x over 1. But regardless, you'll get the same answer. So our answer is x equals negative 8. So I'm going to do this time just to confirm. 17 plus 5 times x, but x is negative 8, equals negative 23. My kids are making noise. 17 plus negative 40, or 17 minus 40, negative 23. Negative 23 is equal to negative 23. That is how you confirm your solutions every time. Just plug it in. Just substitute it back in. So you might say to yourself, oh, this one looks a lot spicy. Spicier. I've got that y in that numerator, and then I have that negative 13. Not a big deal. It's pretty easy to take care of it. So when I look at this thing, I like to do reverse order of operations. If you want to deal with that fraction first, go ahead. But me, I look at this and I'm like, okay, negative 10 equals y over 11 minus 13. I don't like that negative 13 on the right side. There's no variable, my y is not in it, so I don't need to worry about it. I need it off of that side. So I will add 13 to both sides. On the left side, I get negative 10 plus 13 is positive 3. On the right, I get y over 11. Negative 13 plus 13 is 0, so it doesn't do anything. Now I can say I don't like that denominator. I don't like that 11 in the denominator. Y is being divided by 11, so I'll undo that by multiplying both sides by 11. And then simplify. On the left side, I have 11 times 3 is 33. On the right side, I have y times 11 over 11 times 1. So I have 11 over 11. It becomes 1, so it cancels. If you look at it like this, you could just say, all right, cool, it just does that. But regardless, your answer should be y equals 33. So let's look at it. Negative 10 equals 33 over 11 minus 13. 33 over 11 is 3. 3 minus 13 is negative 10. So we have confirmed our solution. You can always do this. There's no need to to get an incorrect response. As long as you plug it in, you can see if it was right and then adjust. Okay, so let's look at this one. Two-step. This one's a little bit faster. You are technically not assigned this one, but it works as well. This is a fractional coefficient. Well, a fast way to deal with that, I have 1/2 y plus 1 equals 2. A fast way to deal with that is, let's just take care of this first. I don't like that plus 1, so I'm going to subtract 1 from both sides. I'm not going to combine unlike terms. 1 minus 1 is 0, so it goes away. 2 minus 1 is 1. Now, the fast way to deal with this is you have a fraction. You can either do it two things. You can either multiply both sides by just 2, but if this were a different numerator, it would make it 2 steps. Or you can just always take the reciprocal of this, which means just flip it over, and multiply both sides by it. On the left, you get 2 times 1 is 2. Over 1 times 2 is 2. That's why cancellation happens. 1 times 2 over 1 is just 2. And then you get 2 over 2 is 1, so you get y equals 2. That's pretty much it. But in general, it doesn't matter what this coefficient is. If this coefficient is different, if it's a 2/3, you'll just multiply by 3/2. As long as the sign stays the same and that you just flip it over, then you're good. So 1/2 times y, but y is 2. 2 over 1 times 2. So 1 times 2 on the top is 2. 2 times 1 is 2, so 2 over 2 is 1. So this cancels, the 2's cancel. And you get a problem that was hiding 1 plus 1 equals 2. 2 equals 2. Confirmed. Now these, y'all freak out because there are more than one variable. You're wanting a number at the end. But here's what's funny about that. You don't need that. You can just solve for whatever you want, and you can have it as expressed that way. This thing, I asked myself what my goal is. My goal is to solve for a. I need a equals something. So I have 9 equals a plus f. I look at the side with a, and I say, all right, well, what's in the way? An f is in the way. What's it doing to my a? It's adding. What's the opposite of addition? Subtraction. Notice I have not changed anything. Everything's still the same. On the left side I have 9, that doesn't combine with anything, minus f, that doesn't combine with anything. And on the right I have a plus f minus f is a plus 0, and I'm done. But Mr. X, can you still confirm this? Absolutely. I know a is equal to this stuff, so anywhere I see a, I can equal that. That works all the time for equations. You can always substitute whatever you want. You can solve for 4 and plug that in instead of 4 if you want. I don't know why you would ever do that, but you could do that. In this case, I could solve for 9 and then have another equation and just plug that, whatever 9 is equal to, into that, as long as that's only for that thing. So I look at this and I'm like, okay, well, let's plug it in. 9 equals a, but a is 9 minus f, and then my plus f. This is my a. It's not division, that's just me boxing it and saying that is a. Okay, well, those parentheses aren't doing anything, nothing's in front of them. So I get 9 minus f plus f. Negative f plus f is 0, so 9 equals 9, confirmed. It doesn't matter if your a is equal to some stuff with variables, that's all fine. Okay, well, let's look at this. I want to solve for b. That's my goal for this one. Solve the following, and then be sure to take into account whether a letter is capitalized or not, because a capital G and a lowercase g in the same equation are different variables. We use those in later math to represent different scaling and different functions. So I have f minus capital G equals 1/4 b. So if something's asking for a capital G and you write in something else, or if you write in the wrong thing, it's not going to count it correct if you put lowercase g in this, because it is not necessarily the same thing. So, but I am looking for b. I have this 1/4 that's in the way. The reciprocal of that is 4/1. So I will multiply both sides, everything, by 4/1. On the right side where my b is, my 4's cancel, my 1's don't do anything, and I'm left with b is equal to this, or if you distribute it, I don't know if it wants you to distribute, try both of them if you need to, but I'm distributing both that 4 onto both of those. So I'm not 100% sure if they're looking for this, which I feel like is more simplified, or this. I think they will probably accept both. But let's go ahead and plug it back in and confirm our solution. F minus G equals 1/4 times, instead of B, I'm going to write what it's equal to. 4F minus 4B. If I'd put this in, it'd be the exact same thing. Okay, F minus G equals 1/4 times 4f plus, or minus, because when I multiply a positive times negative, I get a negative. Negative 1/4 times, it's not a b. G, 4g. Negative times a positive is a negative. That's why this is negative right here. And then I get 1/4 times 4. So on the left side, I'm not doing anything. And on the right side, I get 1/4 times 4 is 1, so I get f. And then right here, negative 1/4 times 4 is 1. Well, negative 1. And then I have my g. So f minus g equals f minus g. You don't have to do this part, but I'm just showing you it always works. Same thing here. I'm solving for a, so I need to get rid of this, not the a. I need to get rid of this. Don't divide by the a. So one step would be, a lot of y'all get really confused. You're like, what do I do on this? Well, this thing is all grouped up, and it doesn't have a inside of it, so we don't care what's in it. But this acts as a single factor because it's a group of stuff times a. So this is the only time when we see a plus or minus sign that we can divide or multiply by it to cancel it. It's because it's all grouped up and acting as a single factor. Let's just say you plug in f and you plug in g, and you know what those numbers are. Once you plug them in and you do all the operations inside of these parentheses, you will just get a single number times a. So if I divide both sides by f cubed plus g, Now, you don't have to put parentheses on it right now. They're not doing anything special, but they won't do anything down here. But you can if you want. If you like it looking at it like I do, you can put those parentheses right there. So my left side is t over f cubed plus g. You can put parentheses, but they don't do anything. And that's equal to f cubed plus g over f cubed plus g. They act as a single factor in this case because the only operation between this and my a is multiplication, and I'm just left with a. But Mr. X, what if I were to plug it in? Go ahead. T into the original equation. T equals f cubed plus g, a. But instead of writing a, I'm going to write what it's equal to. So times, it was originally multiplying, t over f cubed plus g. I can express this over 1 and realize I have this on the top and the bottom, acting as a single factor. If you want to put it back in parentheses, you can. And I get t equals t confirmed. But this was actually a one step, even though it doesn't seem like it. It's just that part confuses y'all. Most of y'all's first instinct is to distribute this onto both of those. Don't. We already have a where we want it. Usually we do something called factoring to get it to look like this, to make it that easy. Multi-step literal equations. Okay, this one's a lot harder, and I don't even know if I assigned it, but let's try it. We're solving for b. I get fb plus 3b equals d. This is a little bit extra. If you do not want to go into this part right now, you can go ahead and stop the video, and you can come back and watch it again later. This is just a little bit extra. This is a little bit harder because it's multi-step literal equations. Now, multi-step we've done a little bit, but we haven't done anything about factoring. But me, I look at this one and I'm like, man, that certainly was easy, just having a out there. So what's different between this and that previous one? Well, it seems to me like someone distributed a b onto f plus 3. Well, let's check that out. We have b in both terms. I wonder if that's what happens. Let's see what happens if I were to have distributed. b times f is bf or fb. It's commutative. Multiplication is commutative. b times 3 is positive 3b. So it turns out this term is this in disguise. So we're going to do something called factoring, which is the opposite. All it is reverse distribution. So if we see a b in both of these terms, we can actually pull it out into like a form that it would have been in if we had not distributed. So instead of writing this, I can say, all right, I'm going to put b times parentheses, and what's in the parentheses is this term divided by that b, or without that b. So fb divided by b, the b cancels, and I get f. 3b divided by b, I get 3. And that's really it. We're just undoing the distribution. Now it looks like our previous problem, so I'm going to divide both sides by this one single factor. It's written as something in parentheses. It's a group of stuff, but I'm going to divide it off because it's one factor times another factor. That's all I care about. As long as there's not plus or minus between this and this, you're good. It's b times that whole group. But this cancels with this, and I get b equals d over f plus 3. This one doesn't require factoring. This one is solving for a. Okay, well, me personally, I'm going to start with this 1/2. So let's multiply both sides by 2. Or 2 over 1, whatever. The 2 divides by 2 and gives me 1, so I'm just left with f on the left when the 2's cancel. And on the right, I'm left with 2d. Okay, well, I am solving for a, so I don't like this f, so I'm going to divide both sides by f. Or multiply both sides by 1 over f. And I get a equals 2d over f. Nothing's changed. It gets a little bit more to think about and a little bit more tedious, but nothing's changed with our solving of equations. And our last one, this one looks spicy. So I'm solving for d. I don't like this negative m. I don't like this 1/7. I don't like this r. So I get f equals negative m plus 1/7 rd. There's a lot of ways to go about this, but I'm going to do it the way of step by step, rather like taking tiny goals as you go through instead of trying to do it all at once. So let's try adding this m to both sides. So on the left side I have f plus m. That's it. They don't combine. They're not the same unknown quantity to the same power. No, not the same factors. Negative m plus m is 0. So I get just 1/7 rd. All right, so I'm getting too annoyed by this fraction. So let's multiply both sides by 7 over 1. But you've got to do it to every term. You've got to make sure it hits everything in both sides. So on the right here, my 7's cancel. That's why I did it. We could have multiplied by 1,000,000 if we wanted to, but it wouldn't have done anything. In this case, multiplying by 7 actually accomplished the goal we wanted of getting rid of 7 on the right side. Okay, so then I'm going to distribute this because I want to simplify both sides. 7 times f is 7f. 7 times m is 7m because they don't have coefficients that are different than 1. And on the right side, my 7's canceled, and I got rd. Okay, last but not least, I don't like this r on the variable I'm looking for, d. So I'm going to divide everything by r. So I will get 7f plus 7m over r. The r is canceled right here, and I get d. Now, you don't have problems like these. These are way too spicy of wrenches. We're not going to try to... When I'm saying we dodge a wrench, we can dodge a ball. We're not going to... We don't need to go this far into it, but this stuff's all possible. It's the same process no matter what you do. The only thing that can make these even spicier are if you have a bunch of like powers that you have to start taking roots, and we're not talking about that yet. But either way, hopefully this was helpful. Y'all have a fantastic day, and finish your Delta Math before tonight.